going to look at some sigma notation, which doesn't seem like it has a place here, but it will come into play a little later. So sigma is just a shorthand for summation. So if I want to add up a bunch of numbers, A1, A2, A3, and we'll continue all the way up to A100. We don't want to have to write this out every time, so we do have a shorthand. We have a capital letter sigma. The bottom we write k equal to 1, and this tells us where we start adding things. The top I'll write 100. This tells us where we end adding things. And then A sub k. Let's look at a couple of examples. I want to add from 1 to 4 of the summation of 4 minus 2k. So essentially what this means is we're going to start by letting k be equal to 1. And I have 4 minus 2 times 1. I'm then going to let k be equal to 2. 4 minus 2 times 2. We then let k be 3. 4 minus 2 times 3. And then k equal to 4. 4 times 2 times 4. And then we can stop because we've reached our 4 that's at the top of this sigma. When I simplify, this is 4 minus 2 plus 4 minus 4 plus 4 minus 6 plus 4 minus 8. And when I do, I get negative 4. So the summation of this is going to be negative 4. Let's look at another one, the summation from 1 to 3 of k squared plus 4. So we start by letting k be 1. I have 1 squared plus 4. We then let k be equal to 2. 2 squared plus 4. And k be equal to 3. 3 squared plus 4. This is now 1 plus 4, plus 4 plus 4, plus 9 plus 4. And when we simplify this, we get 26. Luckily, we do have some shortcuts. While we were able to do these examples relatively simple, if we want our summation to have 500 terms or 1,000 terms or sometimes even more, we don't want to sit there and add up all of these numbers. So we do have some shortcuts. The first looks at when we add from 1 to n of a, just a number, like adding from the summation from 1 to 5 of the number 7. And this is just going to be a times n, however high the summation goes up. If I add from 1 to n of k, so I add 1 plus 2 plus 3 plus 4 plus 5, etc., it's going to be the number I stop at plus or times the next number, all divided by 2. The last one, if I want to add from 1 to n of k squared, so 1 plus 4 plus 9 plus 16 plus 25, I'm going to have n times n plus 1 times 2n plus 1 all over 6. So now that we have these shortcuts, let's look at another example. I have the summation from 1 to 6 of 4k squared minus 2k plus 3. Well, we're going to start with the k squared. K squared said n, which in this case is 6, times n plus 1, 7, times 2n plus 1, which is going to be 13. All over 6. We then have negative 2 times k, and the formula for k said n times n plus 1 over 2. And then when we just add a constant, we do 3 times n, which in this case is 6. As I simplify this a little bit, I get 4 times 91 minus 2 times 21, and then plus 3 times 6. And as I simplify this further, I get that the total sum is 340.